the next half an hour, I'm going to talk about Oracle cloud structure, basically Terraform and Ansible at Elhub. And there will be a few cows. I'll get back to that. A little bit about me. I'm an electrician. I have an automation and IT bachelor. Worked a bit as a developer, Fortran, Python, web. And then I have a social sciences master. And I've worked in Elhub for 6 years, and the last 2.5 I've been in what we call Team Platform, and you'll get to know us a little bit later. I also have 2 kids and a wife, and I do side projects and leave them to rot. And I'm also always interested in podcasts. Sleepwalking is when I push the stroller for my youngest. So if you have any good suggestions for tech podcasts, just let me know, share in the chat maybe. That would be great. This talk is basically about 3 topics. It's about Oracle Cloud Infrastructure, it's about Terraform, and it's about Ansible. And in essence, it's about infrastructure and configuration as peer-reviewed code. As it says on the top there, we have a cloud, we call it Elto Stratus. I blame Trond for that. It's very hard to spell, at least on the keyboard. Yeah, so that's me in the talk. I've done some assumption about you. And every time you see the cow, that is you. And what I've thought about you and Oracle Cloud Infrastructure is that you've maybe never heard about it. At least you haven't used it, and you're wondering why are we not using Amazon Azure or Google Cloud. I think in terms of Terraform, I think you've heard about it. I think you see that it's a powerful tool to manage infrastructure. But if you haven't heard about it, I'll also share a little bit about what it does so that you can follow along. In terms of Ansible, I think you've dabbled a bit. I might be wrong. Here again, I'll go into some basics, but there will also be things that are a bit more into the technical bits of Ansible. All right. As I said, I'm part of Team Platform. It was established in 2019. I was the first member, and we were at the place then when we needed to establish supporting tools and dev environments in a cloud when our current vendor was leaving, and we took that on ourselves. One of the things that we set out to do was to go from these bespoke handcrafted environments that we have to infrastructure and configuration as code, where we know what an environment is. Fast forward to 2022, we are spending a lot more in cloud. That's those dollar signs. The team is around 9, give or take. We now support around 10 Elhub test environments in cloud. I say around because it fluctuates, and also some are just partial. We have to support 30 supporting services, so mocks, development tools, CI/CD, observability and monitoring, secrets, that sort of stuff. And all in all, we have around 300 VMs or so that we manage with these services, but we also have managed services from Oracle Cloud. Co-managed database, some Golden Gate as a service, and the obvious like object storage and such. And the big thing that's happening right now is that we are moving the Elhub production system to the cloud. So that's a process that we are in as an organization. Yeah, okay. So this is still you. Let's talk about technical stuff. Let's start with Terraform. We use, and Terraform is good for, declaring infrastructure. So it's a tool written in Go, where you, in the HashiCorp configuration language, specify the infrastructure. So as an example, an Elhub environment consisting of VMs, storage, networking, load balancers, DNS, and some identity and policy. And when our configuration is set it up in such a way that we can create an Elhub environment using Terraform, so just the infrastructure bit. So these two snippets on the bottom here, that's from a recent build of a performance test environment that we did. So we start Terraform with the configuration, and it plans to add 570 resources in Oracle Cloud. You press yes, go for lunch, and come back, and it's done. When you do it the second time around, Terraform checks is everything there, and it reports no changes. There's nothing to change. The infrastructure is what you specified. So in that way, we can also evolve the infrastructure, meaning that we can add resources, and it will only go and add the one we need. Little bit more specific on the technical details. The way we structure that is that there's something called a Terraform workspace that we say is equal to an environment. So for those of you that work with Terraform, that makes sense. For others, just follow me on this one. So that means that we have a single Git branch. There's no branching strategy for different environments that falls out of sync or whatever problems you have with long-running Git branches. And in essence, this is all we do. We decode the YAML file into a local variable in Terraform for each environment, and then we can use that when we create environments. So for instance, this performance test environment that I talked about have tiers that have maybe 4 or 5 nodes because it's going to handle a lot of load, while other environments, we specify only 1 VM for a tier. So that's an example. And this is inspired after the Ansible group wars, if anyone of you know that. But there's no mechanism that we've found in Terraform to do such a thing. This HashiCorp configuration language could look like this. This is a simplified example. We are using modules, and you can see this local env node count, OSB node count, signifies one of those variables that we load per environment. So for the performance test environment, that variable would maybe be 4, and for another environment, it would maybe be 1. The use of modules allows us to have a very concise configuration of each tier, as we call them. But behind the scenes, that module would maybe create 5 or 6 different resources in the cloud. So there's layers in the configuration. And then what? That's the question. So as I said, I spent waiting about our lunch to get this infrastructure up. We have 20 odd VMs ready to go to be an environment for Elhub. We need to configure it. And I'll talk a little bit about why we chose Ansible to do that work. So one of the things that we could do is just SSH, maybe write some scripts, maybe not, handcraft them like our previous environments. I'm actually going to run this. This is one of the reasons why I chose the presentation tool. So it's just okay, we're creating a file at a certain location with a certain content. That's all. It's a dumb configuration file in this sense. With Ansible, it's a bit more of it's a different way to express it. This is an Ansible ad hoc command. It does the same, but this is a smart configuration file. It looks exactly the same, but it's smart. If we run it, we see that Ansible reports back that it changed something. So this is running on localhost, meaning my machine, and it changed something, meaning this file with this content. But what Ansible also does is that when I run it again, it just reports back success. And it didn't change, so change is false. And that's kind of one of the promises of Ansible. It allows us to do, as in Terraform, declarative configuration of what we want. We wanted this file at this certain location, and Ansible does that for us. It's also idempotent. It doesn't change anything if it doesn't have to. We don't store those commands in version control. Ansible is written in Python, and the playbooks, as they're called in Ansible, are structured in YAML files. So this is the more verbose version of what we just saw, and we invoke that with as a playbook from an Ansible sense. And our playbooks have hundreds of these tasks to configure, for instance, a system to do what we needed to do. I'm just gonna run this as well. It still shows that it did not change anything, and one step was okay. So the idempotence and the declarative nature of the tool is shown in such a way. So why do we like Ansible? We like that it's declarative, at least what we saw here was declarative. We like the idempotence, and there are other places where that is even more important. For instance, if you configure a service, you can use the handler construct to, for instance, say that only if the file changed, restart the service. So it's a very powerful tool to only do what we need to do. Ansible is agentless, meaning that if you're not running on localhost like we're doing here, but on VMs that we created in Oracle Cloud with Terraform, it just packages up the work, ships it to the node, execute, and report back. And so there's no agent running on the node, meaning it's very easy to manage nodes, and there's no pre-install step on the VMs. It's also easy to learn, but it's kind of hard to master. I have the joy of going back to fix playbooks that I wrote 2 years ago. It's interesting, but it's you can do things the Ansible way, and you can do it in a non-Ansible way. It's hard to know what's the best solution always, and it does get messy when we have to do imperative logic. So if the split that we do, we split Terraform and Ansible. They never have anything to do with each other. There's no Terraform invoking Ansible or the other way around. Terraform does its job, and then Ansible picks up after. And the way we, but the exception is that we have some cloud resources that Ansible also steps in to handle, but it's mostly Terraform that does the cloud resources. So what is our glue? How do we make these tools talk? And in essence, it's just strict naming standards and tagging. That's all we do. So we have 5 defined tags: the system, the environment, the component, the type of resource, and the index, for instance, node 1, 2, 3, 4. And we reuse that in both Terraform and Ansible. So, for instance, we set the system and environment both on the Oracle Cloud compartment, which is an access structure in Oracle Cloud. We set it on the workspace. As I talked about, we use that to signify an environment in Terraform. And we can use it in Ansible to target what we need to target. Yeah. Let me be specific. So we created a few VMs. Now we need to target it with Ansible. The tags that we set on the VM allows us to target hosts using the host's specification in the playbooks. So this is targeting that OSB node that we created using Terraform. And then we can do what we want with that. We also we are using dynamic inventory, meaning we get, at runtime, we get the VMs that are in cloud. We fetch that, and we run our Ansible playbooks based on that. And we also have an Ansible wrapper script that ensures that only the specified environment is part of that inventory, as it's called. So when we invoke Ansible to configure a node in everyday work, we can target specific VMs without having to deal with IP addresses, host names, or anything. We just care about these tags. We also do some lookup. So, for instance, the naming standard on display name and having that as code means that we can do lookups based on name, which is a free text field. But the naming standard allows us to do that in Ansible. So I'm hoping it makes sense. But we'll talk a little bit more about Ansible and how we structure all the stuff we do. So we can target the VM, but how do we configure it? What we do at Elhub, an Intune platform, is a heavily use of Ansible roles. That's a construct in Ansible that can be used to group functionality, I would say. And when we write roles, we ensure that we have a clear scope for the role. We version it independently. We prefix everything because Ansible is very the variable hierarchy in Ansible can be a bit tricky, so it's easy if you have naming that is unique. We define all variables in what's called the vars and defaults to create a clear boundary. And in total, that creates a nice abstraction layer for us. So if let's just look at an example. As a caller of a role, this is one of those Ansible playbooks. You would call a role, and on this VM, we want to open up the firewall for certain ports, and also do some allow this user to access cloud metadata. That's what this configuration says. Under the hood, the role does 20-odd tasks to ensure persistence, setting up security-related OCI-specific rules. It masks a few services. It does everything that the caller does not have to think about. So when we say that an Elhub environment have 10 different components or installed software, each of those VMs will have different port openings, and we specify that in this way, and we let the role handle the complexities of Oracle Cloud and just everything under the hood. In the way we structure it is that in a Git repository for a given system, say the Elhub system. There's a directory called Ansible, for instance, Ansible OSB. And here we have multiple Ansible plays. Some invoke roles, like this space place that, for instance, invokes this bootstrap role that does time sync and maybe some OS package configuration. Firewall configuration, authentication, some tuning and hardening, and storage. We would have a monitoring with a couple of monitoring play with a couple of roles there that are invoked. And then this software.yaml is meant to signify the specific thing that we need to do on that VM. So for instance, install a certain software or configure whatever is special with that component that we are setting up. The site.yaml is something that we can call a orchestration play, where we just import the other plays to create a structure. And these are very important for us when we create new environments. We can run one play and everything happens in the sequence that it needs to be. Okay, this is what I think you are wondering. Does it actually work? Ansible breaks down when we have to do, like I said earlier, when we have to do imperative logic and things that Ansible isn't good at, or where there isn't out-of-the-box support to do a certain operation. So we should have used what is called modules in Ansible, but our team does not have a lot of Python competence, and those modules have to be written in Python. So we haven't gotten there yet. So we are just bearing the pain of having everything configured in this YAML language. One of the things we've learned is that in this example, we had some previous efforts to automate infrastructure. And then we tacked Ansible on top. And this is what we ended up with. So we had Ansible to template some scripts on the node, and then Ansible to execute them. And that script did a lot of sed magic, invoked VLST, for those of you that know that, but it's a Jython thing from Oracle. And in the end, it just wrote the configuration file. Very hard to debug, very hard to reason about. When we look at it again, okay, of course, this should have just been templating a config file, which is what you guys learned to do today. So it's this is one of the things that we learned, to simplify and use Ansible in the way that it's good to work with. How do we keep things tidy? That's a tough one. So we have strict naming standards, we have all that, but how do we keep it in line? And the short answer is that we are not able to do that 100%, but we try every day. We have these written standards for naming, for instance, and how we structure things. A lot of the work we do is, of the way that we keep things tidy is through pull requests. So peer review is very important in the work we do. Enforcing naming standards in pull requests is it happens a lot. Also communication, and in stand-ups every morning, if someone is out to tackle some new problem, okay, communicate. Is there a role for that? Should that actually be something that we can share, or should it be? So discussing how to structure is also something that we do. We do a little bit of linting, but maybe not enough. Things that we should get to is more CI, just testing what we do. The test cycle for these sorts of things are painful. Maybe we can do more there. Do more custom linting. If we are able to let custom linting tools find these problems early, or divergence from standard, that would be great. And we are still running things locally. So getting something, a central hub, for instance, AWX or Tower, those are just solutions, with logging would help us in at least debugging work. If some of you wonder, how do you like Oracle Cloud? It works. It has what we need. We are leaning heavily on infrastructure as a service, and it has all the constructs that we need to do what we need to do. We have filed a few bugs to OCI, and they are usually solved. Not all of them. Some we have to just work around. On the Terraform provider for OCI, which is the Oracle Cloud specific part of Terraform, we're basically getting no response. So either our problems is not something that they care about, or they just don't have the capacity. We are getting good response on the Ansible collection if there's trouble there or missing functionality. So I'm guessing that it's different teams with different workloads within Oracle. We don't see a lot of third-party tooling for Oracle Cloud. It is getting better, but the hyperscalers would have, or does have, better tooling, that's for sure. And then the big question. We've spent 2.5 years on infrastructure and configuration as code. Is it worth it? And that's, I'd say yes. The Terraform parts are most definitely worth it. Hand creating 570 resources and assuming that they will be correct, that just wouldn't work. On the Ansible side, we are maybe automating a few things that we could just have left. Things that are hard but easy to do manually. Maybe we could have drawn the line on some parts. But so it does add complexity and effort and time to do this. But I definitely believe that it provides value.